Last week, the Go team published a new blog on two things that I thought were interesting. One is this new gotraceui tool, which is open source. I've been playing with it and I think it's excellent, so I wanted to show you all that. But the other thing that's interesting is they talked about some of the changes they've made in Go 122 to make the overhead of tracing much better. I spoke in this module about how tracing can have a high overhead, and so we need to be careful therefore when we use it. But it looks like now we can get it down from 10-20% CPU to down to 1-2% for many applications. So this is great news. I'll link to this blog post by Felix, which explains a lot more details about how they've achieved this. But they added a new feature too, which is really interesting. They added this thing called flight recording. Flight recording is a really powerful concept that I knew previously from my Java days. And here's a little bit of information about that. So in Java, there's a flight recorder, which is an event recorder built into OpenJDK virtual machine. It can be thought of as a software equivalent of a data flight recorder, which is like a black box in a commercial aircraft. It captures information about the JVM itself and the application running on the JVM. There's a wide variety of data observed, and it can be used for things like memory profiling, allocation profiling, and garbage collection related events. So having this added to the Go library is amazing. So right now it's in this package, which is the X package. So it's not part of the official standard library yet, but I imagine if it continues to see good usage, it will. So they're given an example of how you can use this flight recorder. And it's actually very similar to something I showed previously in this module, but I really like this approach. What they do is they're effectively saying that if a request takes too long, then let's record that trace so we can look into it. So let's take a look at an example of how we can set up an application to take a trace when a request takes too long, write it out to a file, and then also use the new gotrace tool UI to be able to evaluate that trace. So I've wrote a program in Goland here that I'm just going to walk you through, and then we'll set it up to run and see what it does. But effectively what I'm doing is I'm starting a new flight recorder when I start my program, which is the thing we just imported from that new trace package. I'm starting a really basic HTTP server, and I wrote this query function that returns a HTTP handler. So it takes the flight recorder and returns a HTTP handler. And what this is doing is it's calling some slow func, which we'll look at in a sec. And if the response time from that slow function is greater than 300 milliseconds, we're going to write it to a file, which is this traces.out file. Some slow function, all it does is it just does nothing and then gives a delay of between 15 milliseconds and 3000 milliseconds, which is 3 seconds. So effectively this simulates kind of what was in the Go blog post there, where if a request is going to take a long time, then we're going to write to a file. This is really powerful because this means we could effectively set tracing up to exist on our system all the time and just capture like a small portion, a sampled amount of really, really slow requests. And be able to evaluate them later. So I'm going to set this to run now. And you can see it started. So I'm just going to jump over into Postman and make a request. And let's just make sure we get one that's pretty slow. So the first one wasn't slow, this one was slow. And you'll see that if I open the sidebar here, traces.out has been created. If I click it, it's completely useless to us, but it does exist. Cool, so let's open this in the trace UI now and see what we can see. And what I had to do to get this gotraceui running is you can find all the instructions to get it installed here for various machines. The only thing that's different to here to what I did was, for example, if you follow the Mac OS instructions, it says go install gotraceui at latest. I had to do gotraceui at master. It doesn't currently support Go 122 on latest, but it does on master. So if you install at master and run it at master, you'll be able to follow this video along. So go run at master, as I said. And this opens the trace tool, which got a really nice, look cute UI. I'm going to click open trace, and I'm going to navigate to my folder, which is here, and I'm going to open traces.out. And as you can see, it opens a very, very nice looking trace profile that's much nicer than some of the other things I've shown in this tool. There's also a lot of information going on here. So how do we read it? So as you can see, when I've opened the trace, the first thing we see is this timeline view. So as you can see, this is an interactive view. I can hover over things, and 0 is kind of in the center with things to the left and to the right. I think the reason that the 0 was determined to be in the middle is because things happen before and after traces. And that's often what we're looking for when we're evaluating things like this. So having things in the center makes a bunch of sense. Immediately after the axis here, we have a memory plot. So you can see the heap size creeping up on my application before it drops down here. You can also click on specific spans, for example this one in process 3, and it pops up this little side here where you can see the process run, how long that took, without the go routine, and how long it took to unblock here as well. This isn't the best example just because it was so simple, but you can see here that there are different colored coding as well. So green it represents spans that are user work, and purple is used for work that is like garbage collection. In a more complex example, this would be much clearer, I think. You can also click on this go routine tab here, and you can see all the go routines that were involved in the creation of your program. So in one of my previous videos, I showed you how to do this in the typical gotrace tool, and how you could do it inside Golang as well to see what's going on with specific profiles. You can also click Analyze here, and you can click Open Flame Graph. There's nothing very interesting in mine because it doesn't do very much. Or you can open Process Utilization Map as well, which again doesn't show anything very interesting here. But if you head over to the blog that Felix shared, there's a lot more interesting examples in there. This is only my first day using this gotraceui, but I can already see how it's much more accessible. I can see a world where I could share traces with colleagues and they'd be able to open it and be able to understand it a little bit easier than the current Go tool. So I'm really excited to see how development of this progresses. As an exercise, I recommend taking the traces we used in previous parts of this module and running them through this tool and see if you can gather any more information from it and see if it's easier to consume than the tools that we used previously. I hope you enjoyed this brief introduction to flight recording as well as to the gotraceui, and I'll see you in the next video.